The next topic we're going to cover dealing with radicals or square roots is how to deal with them when we're solving an equation. And the main thing I want you to take out of this lesson is we need to get rid of that radical or that square root. And I'm going to show you how to do that. So let's look at a very simple example. Remember, the goal in any equation is to figure out what is y all by itself, or y equals. Or think of it as, what number could I plug in for y that would make this come out to be true? So we're going to peel back the layers and work backwards to figure out what that y has to be. So this says whatever I input, y, must have been square rooted, then I added 6 to equal 12. So to work backwards, I'm going to subtract that 6 that got me to 12. So I would end up with the square root of y equals 6. Well, the opposite of square rooting a number would have been squaring. So if I square this side of the equation, just like I subtracted 6 to get rid of the 6, squaring will get rid of that square root, or cancel it. They're opposites. They're inverse operations. So they're going to undo each other, leaving me just with the y in between. But like subtracting or adding or multiplying to both sides, if I square the left side to get rid of or eliminate that square root, I have to square the right side. And I'm squaring the entire side. So for future reference, let's just think of that as everything on the right side being squared, which in this case would be 36. Now I should always check my solution. So when I check, I take that original number and I say the square root of 36 plus 6, does that really equal 12? Well, the square root of 36 is 6, and 6 plus 6 does equal 12, so this is my solution. And that's the main thing you got to understand. To make this square root go away, I have to square, because that's its opposite operation. Let's look at a second example. This time there's more under the square root, but that doesn't change what I do one bit. The first thing I see is that I need to get rid of this minus 6. So the opposite of subtracting 6 is adding 6. So that eliminates or cancels out the negative 6 on the left side, leaving me just the square root of 4n. And it will equal 0 plus 6 is 6. As soon as I can get one side of the equation all the way down to just a square root, I can square, because the square root and the squared are opposite operations. That will leave me just with the 4n left on the left side. If I square the left side of the equation, I have to square the right side. This time 6 squared is 36. But this time, there's one more step. Square rooting wasn't the final step. Squaring just got rid of that. I still have to divide by 4 to figure out what n is all by itself. So when I divide by 4, I end up getting n is equal to 9. Now before I circle my answer, I need to go back and check. Is the square root of 4 times 9 minus 6 going to equal 0? 4 times 9 is 36. That's being square rooted. Square root of 36 is 6. Minus 6 does equal 0. It checks. So my solution here is 9. Yes, you could guess and check this, some of you, but you're going to want to practice this because the equations will get harder to guess and figure out which number you need. Again, example number 3, more underneath the square root, but it doesn't change what I do. The entire left side of this equation is under a square root. So squaring will eliminate or undo that square root, leaving me just the 3k plus 3 that was underneath to begin with. If I square the left side to make that happen, I have to square the right side. So 6 squared in this case is 36. So now I have a normal looking linear equation that I can solve by subtracting 3 from both sides. Will leave me 3k equals 33. Now I can divide off that lead coefficient of 3, which is going to leave me k equal to 11. Again, I should always double check, so I'm going to check and I'm going to make sure, is the square root of 3 times 11 plus 3 going to give me 6 when I do the order of operations? 3 times 11 is 33. 33 plus 3 is 36, but remember, all of this was under a square root. The square root of 36 is 6. It checks. So my solution is k must be 11 to make this true. Number 4, don't let it scare you. Yes, there's a fraction, but the only thing we're learning today is if there's a square root, the operation that will undo that is squaring. And since the entire left side is being square rooted, I can square to eliminate that back down to just the 3m over 2. That's all that's going to be left. Since I squared the left side, I square the right side. 3 squared is 9. Now I have a normal equation that I have to solve. When you're dealing with that fraction over 2, I like to multiply both sides by that common denominator, because on the left side that will eliminate the fraction, leaving me 3m, and on the right side I'm going to get 18. Finish this by dividing both sides by 3 to eliminate that lead coefficient, and I get that m is equal to 6. I gotta double check, so here's my check. 3 times 6 divided by 2, all of that's under a square root. 3 times 6 is 18 divided by 2, which is 9, but all of that's under a square root. The square root of 9 does equal that 3, so it works. So my solution is m equal to 6. Let's do 2 more, because it does get a little bit harder in the equations that you have to solve once you eliminate the radical or the square root. This time there are 2 square roots, but that's okay. The entire left side of the equation is underneath a square root. So that means I can square the left side of the equation, which will make this eliminate or undo, leaving me just the t squared plus 3 equals. Now that I've chosen to square the left side to get rid of the square root, I have to do the same thing to the other side, no matter what is there. This time, when I square the right side, there's another square root that will eliminate or cancel, leaving me just the 4t underneath that radical. So my square roots have been eliminated, and I'm looking at t squared plus 3 equals 4t. Red light, that's a quadratic equation. I'm going to get 2 solutions. I could factor this, I could complete the square, or I could do quadratic formula. I like to check and see if things factor first. So I'm going to subtract the 4t to the other side, which will give me t squared minus 4t plus 3 equals 0. Looking at that, I do believe that t times t will be t squared. If I do a minus 3 times a minus 1, I'll end up getting the plus 3, but a negative 3 plus negative 1 would be the negative 4. So these are my factors, which means my solution is going to be when t minus 3 is 0, which means t would have to be 3, or when t minus 1 is equal to 0, so t must be 1. And here's why it's very important that you check your solution. It's possible that one of these numbers will work and the other one won't. It's possible that both will work, and it's possible that neither one will work. So we have to check. So let's plug these numbers back in. I'm going to start with 3. 3 squared plus 3 is underneath the square root on the left, and on the right side we'd have 4 times that t, which I said was 3. So I'm going to get 9 plus 3 under a square root, and on the other side I'm going to have 4 times 3, which is 12. Well, 9 plus 3 is 12, so I end up getting the square root of 12 equals the square root of 12. We could reduce that, simplify it down to 2 root 3 equals 2 root 3. That's good practice, but all I'm really checking is that I got the same number, and I did right here. Square root of 12 equals square root of 12. That means that 3 is a solution to this equation. But I didn't check 1. So what I'm going to do is I'm going to go back, and I'm going to make sure that 1 works. So I'm just going to get rid of the 3 here and the 3 here, because remember, that's where I put in the t's. So the t was taking the place of this and this. So I'm going to go back in, and I'm going to put 1. 1 squared and 4 times 1. 1 squared is not 9, and 4 times 1 is not 12. So 1 squared is 1 plus 3, and 4 times 1 is 4. I'm going to end up getting the square root of 4 equals the square root of 4, which 2 equals 2, which is true. So in this case, both of these numbers worked. and t could be 3 or t could be 1, and that's a solution to this equation. There's one more example that I want you to see just in case you run into this. This time the square root's on the right side of the equation. No big deal. I know that I can square to undo a square root, which will leave me with whatever was underneath that square root. This case it's g plus 2. When I square the right side this time, I eliminate the square root, but when I square the left side of the equation, g is everything that's over here, and g squared is simply g squared. So here again, ding, 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 red light, that's a squared, that's a quadratic equation, that's got two solutions. I could factor it, I could complete the square, or I could quadratic formula. Again, I like factoring because it's faster if it works. So I'm going to subtract g and 2 from both sides to make the right side end up being 0. So g squared minus g minus 2 would equal 0. So I know g times g will give me g squared. So it looks like a negative 2 times a positive 1 will end up being my factors for this one. So that's going to give me g could be a negative 1 would make that 0, or g could be a positive 2. I better do my check. So if g is negative 1, is that going to equal the square root of g plus 2? So let's put in that negative 1 and find out. In this case, negative 1 plus 2 is going to be 1, and the square root of 1 does not equal negative 1, which means negative 1 is not a solution to this equation. It was a solution to my quadratic, but it did not plug in and check and make a true statement in the original radical equation. So let's check 2 and see if we get any better results. So the left side of the equation was g, so we're going to put in 2. Does that equal the square root of g plus 2? This time I get the square root of 4, which does equal 2, and it checks. So here's a perfect example where one of the numbers will work. 2 is a solution to this equation, but negative 1 is not. So it's possible to get the quadratic giving me 2 solutions, but I have to check in the original equation to see if it works. So answer the questions on your worksheet and see how well you do.